Hey guys. All right, so let me finish up, and then I'll let you guys go. So then in the book they write it as separate entities, like I did for the first problem, where they would write J2x is equal to this, and then below it D2x is equal to this, and then below it they would write D2y is equal to this quantity, and they wanted to put it in the same line. I just did it this way because it's much better and easier, and I wanted to teach you guys this way, and it'll save a lot of effort later on, but either way is okay. So if you're confused with using these unit vectors, please go ahead and do it the way they do it in the book. If you're okay with using these unit vectors, where each hat represents the different directions, then use it this way because it's just more complete. And this is the general language that's used. So in the end, for this example, let me finish up. We got each component, and then now we add up the components together to get the full component, the full vector. So I'm just going to erase this since we did all this already. So in the end, dr is equal to d1, and then this is in the x direction, so I'll just label it d1x plus d2x plus d3x, right? And then you have the y's, d1y, which is 0 in our case, d2y plus d3y, right? And then if we use the j hats so that we can, the j and I hats, the unit vectors, so that we can combine them, we get this, right? This is the x component of the resultant vector. This is the y component. And then we get the full vector by using these two components. And then remember that we have to put that symbol up there to show that this is a vector now. And then the magnitude of this vector is given by Pythagorean's theorem, where we would take this, so it'd be drx, right? So this is all drx. This is dry squared plus dry squared. And then the angle, if we want to figure it out from the x-axis, is again just tangent of the opposite component, which would be the y component in this case, over drx. And then you plug in these numbers into here and you get your answer. Please go over it in the book. They go over the numbers and complete the problem. So that's it for add-in vectors, and this will set up our tools to analyze two-dimensional kinematic problems, 2- and 3-dimensional kinematic problems. Any questions regarding this? So this section, what we went over in chapter 3, this is one of the most critical areas, and you probably should have seen this already in high school physics. But hopefully at this level. So hopefully it should be a review, but if not, it's okay. I fully went over it, how to do vectorial addition. Any questions, guys? Okay. See you Thursday. Take care.